But I'll do a video lecture if needed. If I don't get through everything, I'll post the rest up as video, and it'll give you time also to prepare, so that if you want to. Here's the deal. Here's our schedule. Wednesday's class is going to be video class. Next Wednesday is the scheduled exam 3. If you'd like, you can move it to April 29th, which is one more week in advance. Since the final is going to be take-home, it's not like you'll be preparing for an in-class exam on the final, so it'll give you more time. And another thing is that you'll get all the questions in exam format that you can use and pull from for the comps for the fall. So there's some advantage to having it on the 29th. The advantage to having it next week is done.
The 29th.
Should we do a hand vote in here?
29.
Ted's sick of preparing for exams.
The sooner it happens, the better in one way, but at 29.
Do you want to do just SurveyMonkey vote? All right, we'll do SurveyMonkey vote. I'm okay either way. It's fine. I just felt like the last test was not that long ago, and then we're having another one. That's all. That's why I just wanted to space them out a little bit. So I'll SurveyMonkey and see how you guys feel. Reply to the SurveyMonkey so that I can total up votes. Okay, we're heading down I think if I look at it, there's really 2 lectures left on content, just content-wise. Because we're doing them by PowerPoint, it moves really fast. So that'll give us time just to work in class on the ideas and come up with a nice take-home final that you can explore some of these ideas. The final topic, which is not on here, kind of petered out, was splitting fields. So we need to do splitting fields last. Doesn't sound nice, right? Just splitting fields. So this is the remainder theorem. If you have a field and a polynomial in the field and you have a constant in that field, the remainder when p of x is divided by x minus c is equal to p of c. This is all stuff that if you're teaching high school and doing long division with polynomials, you think about this a bit. This comes from the division algorithm. If you divide by x minus c, then the leftovers are going to be p of c. And in fact, I'm not sure how you teach this in high school. I actually skimmed over it because we were going 90 miles per hour in pre-calc. But in fact, I believe that if you slowly go through this with synthetic division and long division with students over the reals, that you probably start somewhere like this, looking at what happens when you divide by just a linear factor and see what you have left over, and then how you choose your, I always call it P's and Q's, how you choose your pieces for synthetic division come from it originates from this. So my guess is that you probably show this in class. The proof is division algorithm. By the division algorithm, you can write p of x is equal to x minus c times q of x plus a remainder. That remainder is either going to have degree 0, the remainder is going to be perfect, 0, or the degree of r of x is going to be strictly smaller than the degree of x minus c. Well, the degree of r of x must be less than 1 in that case, so that r of x is either 0 or a constant, meaning a constant in the field. That means that r of x is an element of the field, and it's going to turn out that r of x, that a is going to be p at c. How do you get that? Well, you just plug in c, and you get p at c is equal to r of c. So that r of c is p of c. Well, it's a constant, so that constant term is p of c. Wish all proofs could be like that. I didn't formally define the root, but we did start talking about roots. It's, again, one of the nice things if you're teaching abstract algebra to Georgia Tech students, then which is not required there, unbelievably. I never took it. So if you teach it to Georgia Tech students, what will happen to us is we'll start teaching calculus and differential equations as TAs there. So nobody teaches algebra. We forget all these things, and we don't think about them. So for you guys, actually, you're a step up because you're teaching the material. So everybody knows what a root is. They know what a root is there too, but you forget things like the factor theorems that you use in high school algebra. But a root is what a root should be, that it, you plug in the value and you get the additive identity as the result. So remember, that's the additive identity, zeroth element. So if I have a field, this is called the factor theorem, which you probably present to students. Let f be a field and p of x is a polynomial, then and c is an f, then c is a root if and only if x minus c is a factor of p of x. That I did teach in pre-calculus. So I have an in-class assignment. They should be fairly easy and straightforward, so I just want you to interact so that Crystal can wake you up.